Hi everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is a pure Mathematics 3 for October-November 2023, and the code is 9709/32. So let's move on to question number 1. Question number 1a. Sketch the graph of y equals to modulus of 4x minus 2. So to sketch the modulus graph, firstly I will ignore the modulus, which means I'm sketching y equals to 4x minus 2 first. Okay, so since this is a straight line, then we just need to get 2 points. When the x equals to 0, the y equals to 4 times 0 minus 2, which is minus 2. Okay, and then when y equals to 0, I will be getting 0 equals to 4x minus 2. That means 4x equals to 2. Therefore, the x is going to be 2 over 4, which is half. Then from here, I'm getting 2 points. So the first point with coordinates 0 minus 2, and the second point with coordinates half 0. Okay, so now when we sketch, right, so let's say here is minus 1, minus 2, this is 1, here is 2, then here is 1. Right, this is x and this is the y. Now, the 2 points will be 0 minus 2, which means here. And then this is 0. Okay, another point is at half 0. This is half 0. So now, for your information, because we are sketching modulus, so for the dotted line, for the negative y value, I will use dotted line. Okay, right after that, it will be a straight line. Okay, and then now for the modulus graph, we have to reflect the negative values. That means the dotted line will be reflected. So instead of 0 minus 2, now becomes 0, 2. Okay, so now just join the 2 points and you will get the line. So this is y equals to, or say this is y equals to modulus of 4x minus 2. Okay, so the dotted line should be erased. Alright, so done for the A. Now let's move on to question number 1b. Solve the inequality. Just now we have sketched this graph. So to solve this inequality, we have 2 methods. The first one is using the graph. Okay, add on another straight line here. Add this straight line on the same graph and then find the intersection points. So if I don't want to use that method, then I'm going to use the definition of modulus x. So for information, modulus x is same as square root of x squared. Therefore, by using this definition, I will be getting 1 plus 3x less than square root of 4x minus 2. Then square it. Okay, now to eliminate the square roots, I have to square both sides. So then the square and square root will be cancelled off. That means you will be getting quadratic expansion, quadratic functions on both sides. So then now, when quadratic function, so expand using this formula, a plus minus b squared, it will be a squared plus minus 2ab plus b squared. Okay, then here you will be getting 1 plus 6x plus 9x squared less than 16x squared minus 16x plus 4. Okay, according to this quadratic formula or quadratic expansion. So now I will move all the terms to the right side. So 16x squared minus 9x squared, you will be getting 7x squared. And then this negative 16x minus 6x, it will be negative 22x. At last, 4 minus 1, it will be plus 3. Then when all the terms on the right side, so it will be more than 0. Okay, then from here, this quadratic inequality can be factorized into x minus 3 and 7x minus 1 is greater than 0. Then now, to get the solution of this, we need to sketch a graph of the previous step. Okay, so when you look at this positive 7x squared, that means this graph will have a minimum point. And then the intersection points here will be having the coordinates of x minus 3 equals to 0 means x equals to 3. And then this, when you let this factor be 0, your x is 1 over 7. That means I will be getting 1 over 7 and positive 3. This will be the x. Final answer, okay, it depends on this inequality, which is greater than 0. So when greater than 0 means it will be above the x-axis. So from the graph, I know that my solution is x less than 1 over 7 or x greater than 3. But then be reminded that the original question was only one square or one modulus. But then we use a definition. After that, you square both sides. Okay, so now we have to do the checking. So this is for checking whether we can accept both or not. So when x less than 1 over 7, I will let x be 0. So when x goes to 0, I have to substitute into this left and right side. That means my left hand side will be 1 plus 3x. So 3 times 0, which is 1. Then the right hand side is going to be modulus of 4x minus 2. That means this is going to be modulus of negative 2, and it is same as 2. So from here, we will notice that left hand side is less than right hand side. Okay, which is tally with the inequality, which is left hand side less than right hand side. Then now, checking for the next answer. This is also checking. So when x is greater than 3, let's say x equals to 4. Okay, again, my left hand side, it will be 1 plus 3 times 4. That means this is going to be 13. And then for the right hand side, it will be modulus of 4x minus 2. Then you will be getting 14. And again, the left hand side is less than right hand side. Okay, so which means now my final answer will be both inequalities. Alright, so you have to do the checking when you only have one modulus. Okay, if both sides also modulus, then no need to do the checking. So that's the solution of this question 1b. Now for question number 2, the parametric equations of a curve are x equals to square of ln t and y equals to exponential 2 minus t squared, whereby the t is greater than 0. Find the gradients of the curve at the points where t equals to e, simplifying your answer. So the gradients here is actually referring to the dy over dx. Right, so now x equals to square of ln t, then the y equals to e 2 negative t squared. Okay, so from here, to differentiate the function to the degree n, differentiate fx to the degree n. So here, bring down the n, then fx to the power of n minus 1, and then differentiate fx, it will be f prime x. Alright, so now when I apply this formula, my dx over dt, you need to bring down the 2. Then remain the ln t, which is our fx, and then now the degree, you go to minus 1. So 2 minus 1 is 1. And then now when you differentiate the function, that means now we need to differentiate ln t. So differentiate ln fx, it will be over fx, whatever after the ln, just write down in the denominator, and then numerator is a differentiation of the denominator, which means it's f prime x. So from here, when I differentiate ln t itself, it will be over t first, then differentiate t with respect to t, it is 1. Then from here, I will be getting 2 ln t over t as my dx over dt. Okay, now for the dy over dt, to differentiate the exponential function. So now, differentiate exponential function. What we need to do is we just rewrite the whole exponential function and then differentiate the power of the e. Okay, which means it's f prime x. So from here, I will be getting, rewrite the whole exponential function, and then I differentiate the power of e. So when you differentiate 2 minus t squared, it will be negative 2t. So when I rearrange, then you'll be getting negative 2t exponential 2 minus t squared. Okay, and now we need to get the gradient of the curve, which means it's the dy over dx. So I will write dy over dx equals to dy over dt times dt over dx. That means this is going to be negative 2te 2 minus t squared. The dt dx, okay, for your information, we have found dx dt here, and then we need the dt dx. So dt dx is basically 1 over dx over dt. Okay, that means now I have to switch these two numerator, this numerator and denominator. That means it's going to be t over 2 ln t. Okay, then now from here I will be getting okay, if you want to simplify, you can cancel off the 2 first and then combine all together. Then that will be negative t squared exponential 2 minus t squared over ln t. Okay, that is our expression for dy dx. But then when you look at the question, you need to find what is the value. That is the gradient of the curve when the t equals to e. So which means when t equals to e, our dy over dx, which is a gradient of the curve, it becomes negative e squared times e 2 minus t squared. Okay, just replace the t by e. So this is going to be e squared. Then divided by ln e. So we know that ln e is 1. This is 1. Okay, and then now here you have 2 same base. So for 2 same base, we use this formula. A degree m times a degree n, it will be a degree m plus n. Okay, because of the multiplication, so we add the degrees. Right, which means now I will be getting equals to negative e. So plus both degrees. So then you will be getting negative e. 2 plus 2 is 4, then minus e squared. So that is the dy over dx. Okay, so done for this question. Question number 3. The polynomial, this polynomial is denoted by px, is given that px is divisible by 2x minus 1. So divisible by 2x minus 1 means that the remainder is 0. Okay, when it is divided by 2x minus 1, or I would say that the 2x minus 1 is a factor, and that px is divided by x plus 1, the remainder is 12. Okay, so since this is divisible by 2x minus 1, okay, so I will have to write the remainder will be 0. Okay, so let 2x minus 1 be 0 first to get the x value. So it will be half, which means, right, p half equals to 0. That's the meaning of divisible by 2x minus 1, or 2x minus 1 is a factor of px. So now you replace the px by 0. At the same time, the x here will be replaced by half. Then you'll be getting the two values. Okay, so because you need to find, you will be getting the first equation because you need to find two unknowns, a and b. Therefore, we need to solve the simultaneous equations. So I will write 0 equals to 2 times half cube plus a times half squared minus 11 times half, then plus b. Okay, so 2 times half cube, you will get 1 over 4. Then half squared is 1 over 4, so 1 over 4a. Then the next term is negative 11 over 2, then plus b. Then from here, my b is going to be negative 1 over 4a plus 21 over 4. So let this be the first equation. So you move all the terms to the left side. Okay. Now, when it is divided by x plus 1, the remainder is 12. So this is the remainder theorem, which means you let the x plus 1 be 0. That means the x is going to be minus 1, Now, since the remainder is 12, when x equals to minus 1, I will write p minus 1 is 12. Okay, then again you substitute into the px, this expression. Now you replace the px by 12 and then the x by minus 1. Okay, then now you will be getting 12 equals to 2 times minus 1 cubed plus a times minus 1 squared minus 11 times minus 1, then plus b. Okay, so from here you will be getting this is minus 2 plus a plus 11 plus b, that equals to 12. So since we have found the b in the first equation, here I also get the b. So which means b is going to be minus a plus 3. This is my second equation. Okay, so now since both also b, I will just equate them. That means you will be getting negative 1 over 4a plus 21 over 4 equals to minus a plus 3. So to get the a, okay, so this minus a move to the left side and the 21 over 4 will be moved to right side. Then from here, minus 1 over 4a plus 1a. That means you will be getting 3 over 4a. Then the right side, 3 minus 21 over 4, it will be minus 9 over 4. Okay, so the 4 will be cancelled off. You'll be getting 3a equals to minus 9. Therefore, your a is minus 3. So once you have found the a, you can substitute into first or second equation to find the b. So definitely the second equation will give you a shorter working or simpler working. So your b is minus a is replaced by minus 3. Then after that, plus another 3. So at last, you'll be getting 6. Therefore, your a is minus 3 and b equals to 6. So that's the solution of this question. Okay, question 4a. On a sketch of an argand diagram, shade the region whose points represent the complex numbers z, satisfying the inequalities modulus z minus 4 minus 3i less than equals to 2 and rez. This is the real part. Okay, real part of z is less equals to 3. So the first one is basically a circle. So then when I write in the general form, it will be z minus 4 plus 3i, then modulus less than 2. That means this is a circle with center 4, 3 because of the 4 plus 3i. And then the radius is 2. Okay, 2 from the right side. And then the rez less equals to 3. So re is the real part. That means it is re x plus yi. Which means this is x less equals to 3. That is our real part. So now we have to sketch the circle. Okay. So let's say this is imaginary axis and here is a real axis. Okay, center is at 4, 3. So radius is 2. That means we need 6 units. Okay, then here also 6 units. Now, the center is at 4, 3. So I say here 4 and this is 3. This is the center. So the radius is 2. That means you plus 2 from 4. So that is 6. And then minus 2 from 4. That is 2. Move it down 2 units. That is at 1. Then up 2 units. So 3 plus 2 is 5. So I need to draw a circle. Okay, so please draw a smooth circle. Right? So then this is going to be modulus z minus 4 minus 3i equals to 2. So then another one is real part, x less equals to 3. When you see this sign, equal sign, that means you have to draw a straight line. So straight line, or I would say that it's a solid line, okay, because of the equal sign. So now when you look at here, this means you can accept all the general points with z, complex number z, that is less than equals to 2, means that it will be on the circumference of the circle and also inside the circle. Okay, and at the same time, you have to satisfy this x less equals to 3, which means your region will be here. Okay, so this is the region. Right? So done for the Argand diagram. Now B, find the greatest value of argument z for points in this region. So now argument is the angle counted from the positive real axis. So that means from here, right, what I will do here is probably I have to use this line. Okay, it will be counted from, okay, so you have to use the ruler and draw a line that touches the point. Okay, and here will be 90 degrees. Right, and now you need to find what is this angle. So when you need to find this angle, right, we know that it will be two parts, because I do not know what is the coordinates of this, what are the coordinates of this point. So now what I need to do is I split it into two parts. Okay, then now from here we know that here is 3 units, this is 4, and this must be 90 degrees. So to get this length, let's say this is the C, the center is C. Okay, center is C. So now the length OC can be found using Pythagoras theorem. That is the hypotenuse. That means it's square root of 3 squared plus 4 squared. Then I will get 5, which means here is 5. Okay, then I can find what is this angle. And then another part is what is the next angle, which means here, what is this angle. So by using this rectangle, this triangle, right angle triangle, so I know the 5, and this is radius. Okay, so the radius is 2. Here is 2. So when you look at the upper triangle here with the dotted, I mean this with the green angle, okay, the question mark angle. So the angle, this 2 is the opposite side. Okay, and this 5 is the hypotenuse. So opposite and hypotenuse, it will be sine. Alright, so now from here I will say that my argument z is basically inverse sine 2 over 5. Okay, that is a green color, plus this blue color. Okay, blue angle. Blue angle, the 3 is the opposite side and the 4 is the adjacent side of the angle. Okay, so when you have opposite and adjacent, that is basically tangent. So I have to use tangent to calculate this. Okay, so for the tangent, I will use inverse tangent 3 over 4. Alright, so when you plus these two together, which is the green color, the green angle, together with the blue angle here. Okay, this is the blue one. This is the first one is a green. The first one is a green. Alright, so now I can just calculate this and leave your answer in radians. Okay, so change the mode to radians, mode of the calculator to radians, and correct to 3 significant figures. Then from here you will be getting 1.06 radians. Okay, so that is the greatest argument Z. Okay, so done for this question. Now question number 5. Find the exact value of the integration. So now when we look at this integration, this is a rational function. The degree for the numerator, when we do expansion, the highest degree is 2 for the x. Then the denominator also 2, which means now you are given the improper rational function. Therefore, we need to solve using polynomial division before the partial fractions, okay, or before other methods. So now 0 to 6 x bracket x plus 1 over x squared plus 4. So from here I need to carry out the polynomial division. So before that I will do expansion for the numerator first. It will be x squared plus x. Then the denominator will be x squared plus 4. Then now I will carry out the division. So x squared plus x divided by x squared plus 4. So in order to get x squared from x squared, I need to times by 1. Okay, my 1 I will write it here. So it will be x squared plus 4. Then after that, when you minus, right, so the x squared, when you minus with x squared, it will be 0. So the x minus nothing means it is x. Then here is basically plus 0. So 0 minus plus 4, it will be minus 4. Okay, so now since the remainder degree for the x is 1 now, which is less than the divisor degree, which is 2, then we can stop this polynomial division. That means this is going to be integrate 0 to 6, 1 plus remainder x minus 4 over the divisor x squared plus 4 dx. Okay, so now the next step is going to be splitting the x minus 4 over x squared plus 4. So I will split it into two functions. That means it's going to be integrate from 0 to 6, 1, okay, dx, plus integrate x over x squared plus 4 dx. Then I minus 4 integrate 1 over x squared plus 4 dx. So I split it into three integrations. Then now for information, the first one should be no problem, but the second one we need to integrate it using ln formula, which means integrate f prime x over fx dx. You will be getting ln fx plus c. Okay, so now what I need to do here is I will rewrite all the integration first and change to the form. Okay, so by using this formula, numerator is the differentiation of denominator, which means when I differentiate x squared plus 4, I should get 2x. But then when you compare this and the previous step, right, I have extra 2. So to eliminate the 2, I need to times half outside. Okay, and then for the third integration, we need to apply another formula, which is integrate 1 over a squared plus x squared dx. This is going to be 1 over a inverse tangent x over a plus c. Okay, so means now I will write minus 4 integrate 1 over x squared plus 2 squared dx. That means now my a is 2. Okay, according to this formula, then I can apply the formula directly. So now, since this is 6, sorry, mistake. Okay, so when integrate 1 dx, it will be x. I will group all together because they are sharing the same limits. Then for the second integration, it's going to be half ln x squared plus 4. Okay, the third integration is minus 4. Integrate 1 over x squared plus a squared. So your a is 2. Then I will be getting 1 over 2 inverse tangent x over 2. Okay, there's no plus c here because you are given definite integrals. So now replace the x by 6. So I will get 6 plus half ln. So when you replace the 6 here, 6 squared is 36. 36 plus 4 becomes 40. So now the next one is the 2 and half can be cancelled off. Here is 2. Then I will be getting 2 inverse tangent. So 6 over 2 is 3. And then now minus when the x equals to 0. So first term is 0. Second term is half ln 4. Okay, and third term will be inverse tangent 0. So I will get negative 2 inverse tangent 0. So for your information, inverse tangent 0 is 0. That means whole bracket, that means the second bracket I only get the middle term. The rest will be cancelled off. Then from here, right, the question says find the exact value. So it means that no decimal. Then I will have to rewrite 6 plus half ln 40. Okay, and rewrite the inverse tangent 3 as well. Then this minus, you bring it in, it will be negative half ln 4. So to get the simplest form, I notice that the ln can be simplified. Alright, so I will rewrite first and third term. So the highlighted one will be having the common term of half. So I will write plus half, then ln 40 minus ln 4. So the two ln can be simplified using this formula. Ln A minus ln B is ln A over B. So now, by using the formula, you will get 6 minus 2 inverse tangent 3 plus half ln 40 over 4. So 40 over 4, it is 10. Then that will be the simplest answer. Okay, so this is the integration answer. Okay, now question number 6. A. By sketching a suitable pair of graphs, show that the equation cotangent x equals to 2 minus cos x has one root in this interval, 0 to half pi. So now, for the cotangent x, just for information, right, we need to refer to 1 over tangent x. Right, cotangent x is 1 over tangent x. So now, for the tangent x, for your information, this is our graph. So here is pi. This is pi over 2. Okay, here is 3 over 2 pi and then 2 pi. This is for tangent graph. Now, for the cotangent, what we need to do is, I will just draw it here. So, you need to show that it has one root between 0 and half pi. That means now, I will label, here is 0, this is half pi. Okay, so I will just sketch up to half pi. And then, here is my graph. So, when it is at 0, you see, when tangent x, when x, then this is tangent x, this is cotangent x. When x is 0, tangent x is 0. So cotangent x is 1 over tangent x, means 1 over 0 is infinity. Okay, when this is pi over 2, tangent pi over 2 is infinity based on this graph. So 1 over a huge number, it will be a small number and tends to 0. So then from here, I will get my point, my graph. So when 0, it will be infinity. Because this is positive, so going up, it will be going down until pi over 2. Okay, so let me draw a smooth graph. So this is my cotangent x. Now another graph is 2 minus cos x. So for the 2 minus cos x, let's say y equals to cos x. My graph is going to be this. So here is pi, this is half pi. Here is 1. So now, if it is cos x, if it is negative cos x, means it will be upside down. So I will get like this. So this is going to be pi. Okay, half pi is over here. Here is minus 1. And then for the 2 minus cos x, right, that means this 2 minus cos x is same as minus cos x plus 2. So now you are moving up the graph 2 units. Instead of minus 1, okay, now you can just check here. When here x, here is cos x, negative cos x, and then this is minus cos x plus 2. Okay, when x is 0, minus cos x is minus 1. Refer to the second graph. Right? So minus 1 plus 2, I get 1. And then when it is at pi, at pi over 2, the cos x, the negative cos x will be 0. Then here 0 plus 2, it becomes 2. So now here, right, let's say here is 1. This is 2. Now I will get 0, 1. So 0, 1. And then pi over 2 is 2. The shape will be exactly same as this. So I will just sketch like that. Okay, so here is 0, right? That means, let me draw a nicer graph. Okay, so we are not showing up to pi. So I will just do it like this. Okay, so now when it is the graph, okay, so from here, basically, I will just label this as y equals to 2 minus cos x. And then the other one is y equals to cot x. Okay, we just sketch up to here. Then now, obviously, there's only one intersection point. Right, so only the blue color is the actual graph. The rest of them will be the working. Right, so that's why I show you step by step here. So from here, you can just write from the graphs. Okay, there's only one intersection point. Hence, the equation only has one root for x between 0 and half pi. Okay, so that's all for this graph. Now, B, show by calculation that this root lies between 0.6 and 0.8. So, to show the location of the root, you refer to the original question, cot x equals to 2 minus cos x. So, cot x equals to 2 minus cosine x. Then from here, I will move all the terms on the right side to the left side. So once I move I will be getting cot x minus 2 plus cos x equals to 0. And then I will let the left hand side be fx. Okay, to show that the root lies between 0.6 and 0.8, now you need to calculate these two values. So it will be cot 0.6 minus 2 plus cos 0.6 and also cot 0.8 minus 2 plus cos 0.8. So now when you calculate, make sure you set your calculator in radians mode. Okay, and then the first value is going to be 0.287, which is greater than 0, and the next value is negative 0.332, which is less than 0. So since you get different sign of these two values, so you just write f 0.6 is greater than 0 and f 0.8 less than 0. Okay, there is a sign change. Hence, this root lies between 0.6 and 0.8. Okay, so done for this part B. Now C, use the iterative formula to determine the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. So first of all, I will copy the formula. Now, since the x lies between 0.6 and 0.8, so you can let the x not be 0.6 or 0.8 or any other numbers in between 0.6 and 0.8. So I will always consider the middle value. Therefore that is 0.7 for my fx x0. Then now my x1, it will be inverse tangent of 1 over 2 minus cos 0.7. And then again, all these calculations must be done in radians mode. Then you will be getting 0.8608. Sorry, 8606. Okay, so now continue with the x2. It will be inverse tangent of 1 over 2 minus cos 0.8606. Then this is going to be 0.6, not 8606, it's 6806. So it is going to be 0.6855. Okay, so if you are not sure when to stop, so now continue with the next value, x3. So x3 is inverse tangent 1 over 2 minus cos 0.6855. And again, this value in radians, it will be 0.6843. So when you compare, right, 685, 684. So normally I will just check on the 2 decimal places. Here also 68. But then when you look at just 2 decimal places here, right, then you will have a doubt. You see here 68, this is 68, this is 68. So if you stop at x2, then you have to conclude your answer based on the x2, which is 0.69 because the next digit is 5. But then when you count the x3, this is 0.6843. So when you round up, it will be just 68. So if you are not sure whether you accept 0.69 or 68, then you calculate one more value. So x4 is inverse tangent of 1 over 2 minus cos 0.6843. And then this is going to be 0.6846. So now, from here, I can just conclude. You see here, 68, 68. The next one is also 4. Okay, here is also 4. So it means that I will refer to the x4 to conclude my x value. So since the 4 is less than 5, therefore my final answer, okay, or my x is approximate to be 0.68. So that's the solution for part C. So for question 7a, by expressing 3 data as 2 data plus data, prove the identity. So now I will start with cos 3 data and then change the 3 data to 2 data plus 1 data. Okay, and then after that, use the formula cos A plus B. This is going to be cos A cos B minus sin A sin B. Okay, so my A is 2 data and my B is 1 data. Then here you will be getting cos 2 data, cos 1 data minus sin 2 data, sin 1 data. And now we need to prove the answer in terms of cos data. Therefore, we have to use the formula cos 2a equals to 2 cos squared a minus 1. That means here is going to be 2 cos squared theta minus 1 multiplied with cos theta. And then the sin 2 theta is going to be 2 sin theta cos theta multiplied with the sin theta. Then now, use the expansion. Okay, just expand it. You will be getting 2 cos cube theta minus cos theta, and then here I will be getting sine squared, right? Sine squared theta, so I will get minus 2 cos theta, and then the sine squared theta I will change to sine squared theta plus cos squared theta is 1. Therefore, my sine squared theta is 1 minus cos squared theta according to the identity. So now I will direct change. So the sine times sine is 1 minus cos squared theta. Okay, and now just rewrite the first two terms and then do expansion. And don't forget there's a minus here. So minus times 2 cos theta times 1, you will be getting minus 2 cos theta. Then the minus 2 cos theta times the minus cos squared theta, it will be plus 2 cos cube theta. Okay, so the first and last term, when you combine, you will get 4 cos cube theta. So the second and third term, when you combine together, is negative 3 cos theta. So with this, we have proven the identity. Alright, so done for the 7a. And now let's move on to 7b. Hence, solve the equation. So this left-hand side, okay, let's check. Cos theta, we have found cos 3 theta. So I will change the cos 3 theta to the given form in the previous part, and the rest just remain. Okay, so I will write cos 3 theta plus cos theta cos 2 theta equals to cos squared theta. So the cos 3 theta we have proven just now, 4 cos cube theta minus 3 cos theta. This one from just the cos 3 theta itself. Then now plus cos theta. Okay, then since you need to solve means that you must get the similar term. So the cos 2 theta I will change to 2 cos squared theta minus 1. That equals to cos squared theta. So now open the brackets and then you do the expansion for the next term. So I will get plus 2 cos cube theta and then minus cos theta. This cos squared I will move to the left side. Okay, so the first and third term, when you plus together, it will be 6 cos cube theta. And then copy the last term first, then followed by the cos theta. So when you solve the cos theta, we have minus 3 cos theta and then minus another theta. Okay, then total will be minus 4 cos theta. So to solve this, the common term is cos theta. I will factorize the cos theta. Then you will get 6 cos squared theta minus cos theta minus 4. Then equals to 0. Now, when the multiplication equals to 0, multiplication of two factors equals to 0, means that one of them must be 0. So now either cos theta equals to 0 or 6 cos squared theta minus cos theta minus 4 equals to 0. Now, when you look at the domain here, okay, or interval of the theta is defined from 0 to 180 degrees, inclusive both. So now for the cos theta equals to 0, I will sketch a cos graph. Here is 360 degrees. Then this is 270. Okay, here is 180 degrees. And then this is 90 degrees. So now obviously when cos theta is 0, I will get 90 and 270. Okay, but then because your theta is in between 0 and 180 degrees, therefore your theta for cos theta equals to 0 means that it will be just 90 degrees. Okay, and then for the right hand side, okay, probably alright. So for the right hand side, the other one, I can factorize this. Okay, we have to solve this using quadratic formula because it cannot be factorized. Alright, so now the quadratic formula, if let's say you need to solve this quadratic equation, your x is minus b plus minus square root of b squared minus 4ac over 2a. So that's why I have to write down the coefficients for all the terms first. So my a is 6, my b is minus 1 because of the minus cos x, then the c is minus 4. Then instead of x in the quadratic equation, now it is cos theta. That means cos theta is minus b plus minus square root of b squared minus 4ac and over 2a. Okay, then from here you will be getting 0.90407. I give more decimal places because this is the working, and another one is negative 0.73740. Okay, so now when you look at this interval, the theta from 0 to 180 degrees, so when the cos theta is positive, I will get the angle in first quadrant. And when the cos theta is negative, I will get the angle in second quadrant. Alright, so for the first quadrant, inverse cos of 0.90407, you will be getting 25.3 degrees. And the next one is going to be 42.5 degrees. Okay, so that means the first angle, just rewrite 25.3, and the second angle is basically this green color, which means you will be getting 180 degrees minus 42.5 degrees. Then I will be getting 25.3, and another one is 137.5 degrees. So my final answer for this whole question is going to be 25.3 degrees, 90 degrees, and 137.5 degrees. Okay, so these are the three. So done for this question. Okay, question number 8. Given the division equals to lambda times 2 minus I, where a and lambda are real constants, a show that 3a squared plus 4a minus 4 equals to 0. So I will copy the question first, rewrite the question. Okay, so now I will move the denominator to the right side. Okay, and then do expansion. So here here just do expansion. Then you will get lambda. So 2 times a plus 2i, it will be 2a plus 4i. And then when you multiply the minus I with the bracket on the right side, second bracket, it will be negative ai, negative 2i squared. Okay, remember I squared is minus 1. So I squared is minus 1. Therefore, this is minus 1. Okay, so I will be getting equals to lambda bracket 2a, so plus 4i minus ai, minus 2 times minus 1 is plus 2. Okay, so now, since the left hand side you have real and imaginary part, then right hand side I better change to real and imaginary part, which means here is lambda of 2a plus 2. This is my real part. Imaginary part is going to be plus lambda 4 minus a times I. Okay, so left hand side is 2 plus 3ai. Now I will compare. So 2 equals to lambda of 2a plus 2. That means my lambda is 2 divided by 2 brackets a plus 1. Okay, by factorizing the 2. Therefore, it's 1 over a plus 1. This is my lambda. Okay, now for the right hand side, I mean for the imaginary part, 3a equals to lambda times 4 minus a. Then now I will just substitute my lambda from the first equation into the second equation. So substitute first into second. I will get 3a equals to 1 over a plus 1 multiplied with 4 minus a. Okay, and then from here, the a plus 1 will be moved up and combined with the 3a. Then I will be getting 3a times a plus 1 equals to 4 minus a. And now the question is asking for showing this quadratic equation. So now just do expansion. It is 3a squared plus 3a equals to 4 minus a. So all the terms move to the left side. Then at last you will be getting the given quadratic equation. So 3a squared plus 4a minus 4 equals to 0. Exactly the same. Alright, so here, just write shown. So this is the working for this part. Okay, next. Hence, find the possible values of a and the corresponding values of lambda. Hence means use the previous answer. So I will have to rewrite the quadratic equation. 3a squared plus 4a minus 4 equals to 0. Then this quadratic equation can be factorized into 3a minus 2 times a plus 2 equals to 0. Then from here, 3a minus 2 equals to 0 or a plus 2 equals to 0, which means either my a equals to 2 over 3 or my a equals to negative 2. That's why it's mentioned possible values of a. So you are getting 2a. Now find the lambda. So refer to previous working. Okay, first equation. Lambda is 1 over a plus 1. So now lambda equals to, this is from first equation, lambda is 1 over a plus 1. So when a equals to 2 over 3, the lambda is 1 over 2 over 3 plus 1. Then you will be getting 1 over 5 divided by 3, which is 3 over 5. Okay, so when a equals to negative 2, your lambda is 1 over negative 2 plus 1, which means this is minus 1. So this is the solution of part B. Okay, next question, number 9. The diagram shows the curve y equals to sine x cos 2x for x between 0 and pi, and the maximum point M, whereby the x equals to a. The shaded region between the curve and the x-axis is denoted by r. Now a, find the value of a correct to 2 decimal places. So now my a is the maximum point, the x-coordinate of the maximum point. So maximum point is found when dy dx equals to 0 first. That means a stationary point. Okay, so my y is sine x cos 2x. So my dy dx, this is obviously the products rule. So d over dx uv, it will be uv prime plus v u prime, products rule. So which means now here my u equals to sine x. So my u prime, differentiate sine x is cos x. Then my v is cos 2x. My v prime, when differentiate cos, is minus sine. Rewrite the 2x. And then differentiate 2x is going to be 2. Okay, so now use the formula, products rule, u v prime. So I will get sine x multiplied with negative 2 sine 2x plus then cos x multiplied with cos 2x. Okay, then from here, it's given that when x equals to a, dy dx equals to 0. So when x equals to a, dy over dx equals to 0. Then I will just write 0 is negative 2. Okay, sine a, sine 2a. So sine a, sine 2a plus cos a, cos 2a. Okay, now to get the a, you have sine a, sine 2a, cos a, cos 2a. So I will change all to cos. Right. So for your information, sine 2a is 2 sine a cos a. So I'm going to change this. And then for this cos 2a, I will use the next formula. Cos 2a is 2 cos square a minus 1. That means from here, I will get 0 equals to negative 2 sine a multiply with 2 sine a cos a. Then plus cos a. The cos 2a will be replaced by 2 cos squared a minus 1. Okay, and then you do expansion. So I will get 4 cos a and then sine squared a. Then this, just do expansion, you will be getting plus 2 cos cube a minus cos a. Okay, now for the first term, you still have the cos, you still have the sine squared. So I need to use the identity. Sine square x plus cos square x is 1. Therefore, sine square x equals to 1 minus cos square x. So I will convert everything to cos. So then 4 cos a, then the cos sine square a will be 1 minus cos square a plus 2 cos cube a minus cos a. Then now when you do expansion, it will be 4 cos. Okay, or no need to do expansion because we need to find the cos, right? I notice that you have the common term over here, which is the cos a. So the common term is cos a, cos, and cos. Alright, so I will factorize a cos a. Then left the 4 over here. So this 4 will be times in. Then you will be getting 4 minus 4 cos squared a plus 2 cos a, because you have taken out the cos a, then minus 1 equals to 0. Okay, then from here, I will get 0 equals to cos a, and then the next one is negative 4 cos squared a plus 2 cos a. 4 minus 1 is 3. Okay, let me check any term I miss out. Okay, I miss out the minus. Look at here. You see, this is the minus. But when come to the next step, my minus is missing. So here you have a minus. This is minus. So this minus you times in. Here is minus. Here is plus. Right. Then I will get cos cube. Okay, and one more is here. This I have taken out degree 1. That means the 2 cos A should be degree 2. Okay, so careless mistake. So now I will rewrite. So this is going to be 4 plus 2 is 6 cos square x. Minus 4 minus 1 is minus 5. Right. Then from here, I will be getting either cos A equals to 0 or 6 cos square A minus 5 equals to 0. Then now let's look at the question. The x is given by 0 to pi. So now 0 to pi. So for the cos graph, okay, again, cos graph. When cos graph is 0, that means it's at pi over 2 and also 3 over 2 pi. This is for the cos graph. That means now when cos A equals to 0, I will get A equals to half pi. Because based on the graph here, your pi is over here, your A is close to the 0. Therefore, the A will be half pi. Okay. Then now, or 6 cos squared A equals to 5. That means cos squared A is 5 over 6. Hence, cos A is plus minus square root of 5 over 6. So then, from here, right, when it is plus, okay, so cos A is plus minus because it will be 0 and pi. So it can be 2 quadrants. So when you consider A is inverse cos square root of 5 over 6, that means you will be getting 0.42 here. Okay, here is also 0.42. That means I will get A is 0.42. My angle will be either this or the bigger one. So the bigger one is pi minus 0.42. Then here I will be getting 0.42. Another one is 2.72. Okay, so I have to count. What is my pi over 2? Pi over 2 is basically 1.57. So now I have 3a values here. So when 3a values, when you check the graph, A is very close to 0. Okay, the origin. That means I have to choose the lowest A. Therefore, my A is 0.42. So that's my A value. Okay, B, find the exact area of the region R, giving your answer in the simplified form. So let's look at the region. So for the R, I need to find these 2 points. So these 2 points happens when the y equals to 0, which means I need to solve sine x cos 2x equals to 0 first. So sine x cos 2x equals to 0. Alright, that means either sine x equals to 0 or cos 2x equals to 0. Then again, when the x is between 0 and pi, right? So for the sine graph, I will just draw it here. This is a sine graph. So when 0 to pi means that it will be 0, that means I will have to consider these 2 points. Okay, so then I will get x equals to 0 or pi. Now for the cos 2x, right, the cos graph. So now what we need to do is, when this is 0, it will be these 2 points. That means this is pi over 2, and then this is going to be 3 pi over 2. Right? So now see, when x is between 0 and pi, now we are solving cos 2x. That means 2x will be between 0 and 2 pi. Right? So this is cos x. Then now, based on the graph, my 2x will be pi over 2 or 3 pi over 2. But then we are solving for x. So x will be pi over 4 or 3 over 4 pi. So now let's check. 0 pi, pi over 4, and 3 over 4 pi. So obviously, okay, this one cannot be 0. Okay, pi already here. That means this is going to be pi over 4. Here is 3 over 4 pi. Alright, so now I have to integrate the graph from pi over 4 to 3 over 4 pi. But look at the region R. The region R is below the x-axis. Means when I consider the integration later on, I have to put a modulus to make sure that it is positive for the area. Okay, because area of the region below the x-axis, it will be negative if you just direct apply the integration formula. So integrate from pi over 4 to 3 pi over 4. The graph, okay, let's look at the graph first. It will be sine x cos 2x with the modulus later on, dx. Okay, so now to integrate this, I will change the cos 2x to 2 cos square x minus 1. Okay, use the double angle formula. Then now here I will do expansion. So I split it into 2 integrations. You will get 2 sine x cos square x dx minus integrate from pi over 4 to 3 pi over 4, then sine x dx. Right, so now for the first integration, I'm going to use the substitution method. Let u be cos x. Then now du over dx, it will be negative sine x. Then now when you look at the question here, I have sine x dx, means the dx I will move up, which means I will be getting du equals to negative sine x dx. So the minus I can move to the other side. So just write negative du equals to sine x dx. Okay, so then now don't forget to pre-calculate the limits. So when x equals to pi over 4, the u is cos pi over 4. This is 1 over square root 2. When x equals to 3 pi over 4, the u is cos 3 over 4 pi. This is negative 1 over square root 2. That means now my area is integrate. Okay, so limits will be 1 over square root 2 to negative 1 over square root 2. Then 2 sine x dx. The sine x dx is negative, so I will write negative 2 du. Then cos square x will be replaced by u squared. Okay, and put the modulus. Then the next integration just rewrite because this is a simple integration. Okay, so next step, just integrate directly. minus 2. Then this is u cubed over 3. Limits 1 over root 2 to negative 1 over root 2. Minus integrate sign is actually negative cos. So I will just write plus cos here because you are integrating negative sign. Therefore, it is plus cos x. So these are the two limits. And then now you simplify. So I will write negative 2 over 3. Then negative 1 over root 2 cube minus 1 over root 2 cube. Okay, plus cos 3 pi over 4 minus cos pi over 4. So when we simplify all of this, so you will be getting negative 2 over 3 times negative 1 over 2 root 2 minus 1 over 2 root 2. Then plus negative 1 over root 2 for the cos 3 over 4 pi. And then the cos pi over 4 is 1 over root 2. Okay, so from here, at last, you will be getting, okay, now you see here, these two can be cancelled off. Okay, then at last you will be getting 2 over 3 root 2 minus 2 over root 2. So then it will be negative 2 root 2 over 3. Then at last, okay, you will be getting 2 root 2 over 3. So this is the exact area. Okay, next question 10. The equations of the lines L and M are given by L is this and this is the M, where C is a positive constant. Given that the angle between L and M is 60 degrees, find the value of C. Okay, so now for your information, let's say this is L. Here is M. So for the L, you will have B1. This is the B1. Okay, for the M, you will have B2. And then the angle is theta. So this is our B2. So which means now let B1 equals to 112 and then B2 is negative 2 for C. So B1 dot B2 equals to magnitude B1 magnitude B2 cos 60 degrees. Okay, because the angle is 60. So now 112 dot negative 2 for C equals to square root of 1 square plus 1 square plus 2 squared. That will be the magnitude of the B1. And then the magnitude of B2 is square root of squares of minus 2 plus 4 square plus C squared. Then cos 60 is basically half. So for the left hand side, for the scalar products formula, okay, so just multiply and plus together. Then you will be getting 1 times negative 2 plus 1 times 4 plus 2 times C. For the first square root, that is square root 6. The second square root, you will be getting square root of 20 plus C. Then remain the half. So for the left hand side, minus 2 plus 4 is 2. So 2 plus 2C equals to square root 6 square root 20 plus C times half. So then from here, you can just times the whole equation by 2. So I will get 4 plus 4C equals to square root of 6 times 20 plus C. So the half will be cancelled off. We have one formula here. Square root AB equals to square root A times square root B. That's why I combine the two square roots. Then now from here, you will be getting this equation. So to solve the C, we need to square both sides. So, okay, I found a mistake. This is c squared, so this is a squared for the c. So now what to do is the square and square root will be cancelled off for the right side. Then now for the left hand side, you need to do expansion. This is 16 plus 32c plus 16c squared. Then right hand side will be 6 times 20, 120 plus 6c squared. Okay, now all the terms move to the left side. So then I will be getting 16c squared minus 6c squared is 10c squared. Then plus 32c, 16 minus 120, it will be negative 104. Okay, this quadratic equation can be factorized into c minus 2 and 5c plus 26. That means either c minus 2 equals to 0 or 5c plus 26 equals to 0. Therefore, your c equals to 2 or c equals to negative 26 over 5. Now, let's check the question. It's mentioned c is a positive constant. Therefore, now given c is a positive constant, therefore your c is just 2. So that's the solution of this part. Next question. Show that the length of the perpendicular from this point to L is square root 11. Okay, so now what to do here is I will rewrite my L. The B1, okay, go back to the L. The B1 is 112. So here is 112. Let's say this is the point. 6 minus 3, 6. You need to find length of the perpendicular from this point to the line. Let's say this is P, here is Q. Here is 90 degrees. Alright, so now let Q lies on L. That means OQ equals to RL. Okay, the RL is given in the previous part. So I will copy this. It will be 3, negative 2, 1 plus lambda 1, 1, 2, which is same as 3 plus lambda, negative 2 plus lambda, and then 1 plus 2 lambda. That is my OP. OQ. So since PQ is perpendicular to the B1, okay, that means I have to use a cross product. I will have to use the scalar product later on. The scalar product of these two vectors will be 0. So now I have to find my PQ first. Okay, I will let my OP be 6 minus 3, 6. So 6 minus 3, 6. Convert the point form to the vector form. Then this is OQ minus OP. So this is going to be 3 plus lambda, negative 2 plus lambda, 1 plus 2 lambda, minus the OP will be 6 minus 3, 6. Then this is going to be minus 3 plus lambda. So minus 2 minus minus 3 is 1. Then plus lambda. 1 minus 6 is minus 5 plus 2 lambda. Okay, and then from this diagram, we know that PQ dot B1 equals to 0. So I will write minus 3 plus lambda, 1 plus lambda, minus 5 plus 2 lambda dot B1 is the direction vector in the line L, 1, 1, 2. Okay, now you want to show that the length of the perpendicular from the P to L is square root 11. Means that you want to show the length of PQ is square root 11. So then I have to find the PQ first. Before I get the vector PQ, I need to find the lambda because my PQ depends on lambda. So now again, this is scalar product. So 1 times minus 3 plus lambda plus 1 times 1 plus lambda plus 2 times minus 5 plus 2 lambda equals to 0. So just do expansion. It will be minus 3 plus lambda plus 1 plus lambda minus 10 plus 4 lambda equals to 0. Then you will be getting 6 lambda equals to 12. Therefore, lambda is 2. Once you find the lambda, you substitute into this PQ. Okay, get the vector first before we get the magnitude. So this is going to be minus 3 plus 2, because the lambda is 2. Then 1 plus 2. After that, minus 5 plus 2 times 2. So then this is minus 1, 3, and minus 1. Okay, this is a vector PQ. Therefore, the length PQ is the square root of minus 1 squared plus 3 squared plus minus 1 squared. So at last, you are getting square root 11. So this is the perpendicular length. Okay, next. Question 11. The variables x and y satisfy the differential equation. Given x is 1 and y equals to 1, A solve the differential equation to obtain y in terms of x. So now, x squared dy over dx plus y squared plus y equals to 0. What I need to do is I will move the y, the terms with the y to the right side. So x squared dy over dx equals to minus y squared minus y. Then the minus can be factorized. Then here I will get x squared dy over dx. Okay, so now I will move the dy, because the dy is the numerator. So all your y should be on the left side, and then the x should be on the right side. So it means that now I will be getting negative 1 over y squared plus y dy equals to 1 over x squared dx, and then integrate both sides. Okay, so for the left hand side, I got to integrate this using the partial fractions, but before that I need to factorize the y first. Right hand side, I need to move up the x squared, becomes x degree negative 2. So let's find the partial fractions. This is improper rational function. Sorry, this is proper rational function because there's no y in the numerator, and the degree of the y in the denominator is 2. So here will be a over y plus b over y plus 1. Okay, so now get the same denominator. So when we get the same denominator, you always compare with the left hand side. So now you are given y, so it means that you need to times with y plus 1 for the right hand side. So I times y plus 1 and divide by y plus 1. Then plus b over y plus 1. So then here I need to multiply with the y at this moment. Okay, so you times y over y. Once you are getting the same denominator, I will be getting 1 equals to a bracket y plus 1 plus b bracket y. And then to get the a and b, just let the factor be 0. So let y plus 1 equals to 0. Hence my y is minus 1. Therefore, 1 equals to b times minus 1. So obviously the b is negative 1 because I already let the y plus 1 be 0. Now, the next is let the y be 0. So I will be getting 1 equals to a bracket 1. Therefore, my a is 1. Okay, so now I rewrite my partial fractions. 1 over y bracket y plus 1 is a over y plus b. So b is minus, so the plus and minus becomes minus 1 over y plus 1. Okay, so now I will substitute these partial fractions into the integration over here. Okay, so don't forget there's a minus. So I times minus to these two terms, it will be negative 1 over y plus 1 over y plus 1 dy on the left side, and right side remains as integration of x degree negative 2 dx. So for the left hand side, to integrate 1 over y, negative 1 over y, or 1 over y plus 1, we need to use the ln. Okay, so this is the formula. I use this because when I differentiate y, I get 1. Differentiate y plus 1 is also 1. Therefore, I will be getting negative ln y plus ln of y plus 1. For the right hand side, to integrate that, integrate ax plus b. Okay, or probably I will just use this formula. Okay, x degree n. It will be x degree n plus 1 over n plus 1, then plus c. Okay, provided the n is not minus 1. So now the n is minus 2, you can just direct replace. So I will get x power minus 2 plus 1 is minus 1 over minus 1 plus c. So I will rewrite this. Okay, so it will be left hand side, I may combine. So ln a minus ln b is ln a over b. Okay, so I combine first. This is ln y plus 1 over y. Right hand side, negative 1 over x. Because x degree negative 1, you bring it down. Now, to find the c, let x be 1, y be 1. So, x equals to 1, y equals to 1. Therefore, ln 1 plus 1 is 2. So, 2 over 1 equals to negative 1 plus c. So, I'll get ln 2 plus 1 is c. Okay, so now final answer, substitute back into this expression. So I will get ln y plus 1 over y equals to negative 1 over x plus the c. C is ln 2 plus 1. So now to get the y as a subject, when you refer back to the question, get the y in terms of x. So it means that I need to eliminate the ln. So to eliminate the ln, we have one formula. E ln y equals to y. So just take e both sides. Then from here, I will get e ln y plus 1 over y equals to e negative 1 over x plus, okay, I rewrite 1 plus ln 2. So from here, e ln will be cancelled off, y plus 1 over y on the left side. And then for the right hand side, because e ln, the e ln can be cancelled off. You look at the e ln here. So I will have another formula, ea plus b equals to ea times eb. So I will split it into two terms because I want to simplify the e and ln. So I will get e to the power of negative 1 over x plus 1. Because of the plus, alright, times e ln 2. Therefore, from here, my y plus 1, this denominator, I will move up. Okay, so when I move up, I will get y bracket. Then e, instead of e power negative 1 over x plus 1, I write 1 minus 1 over x. Then the e ln 2 becomes 2. Right? So from here, I will get 2y e 1 minus 1 over x equals to y plus 1. So to get the y as a subject, I will move the y on the left side to the right hand side and then factorize the y. So I will write 1 equals to 2y e 1 minus 1 over x, then minus y. And then now here I factorize the y, I will get 2e 1 minus 1 over x minus 1. Here is the 1. Hence my y is 1 divided by 2e to the power of 1 minus 1 over x, then minus 1. So this is my solution. Okay, done for this part. And then B states what happens to the value of y when x tends to infinity. Give your answer in exact form. So when the x tends to infinity, when you look at the y over here, I will get e to the power of 1 minus 1 over x. So the 1 over x will tend to 0, right? I will say 1 over x, e 1 over 1 minus 1 over x will tend to e 1 minus 0, because 1 over infinity is 0. Then therefore this tends to e degree 1. Okay, so therefore I will just write my y equals to 1 over 2e 1 minus 1 over x, then minus 1. So when x tends to infinity, my y will tend to 1 over 2. This whole e you need to replace by just e itself. Therefore, this will be e minus 1. Okay, that's the solution of the part B. Okay, so we have come to the end of the video. Thanks for watching. Please like and subscribe this. Please like this video and subscribe to the channel if you enjoy watching this video, and also stay tuned for more upcoming videos. Thank you. Bye.